So this is a walkthrough of integration that we are discussing right now. So we're starting from 8.2. Okay. Can you tell me when I do derivative, what am I actually finding?
You're
The
finding the
gradient.
gradient.
So when I do derivative, I say dy by dx is going to give me the gradient. Yes.
Yeah.
I start from y, I remove the derivative, I get my dy by dx, which is my gradient. If I am going to do my antiderivative, that means from the gradient, from the dy by dx, I want to know my actual function. What do I do?
Yeah.
What do you do?
You integrate it.
You
Integrate.
integrate it. Okay. So the main reason why you integrate is you want to know the area under the curve. So at any place or any situation, you want to find out the area under the curve. What you are going to do is what? What you're going to do is
I'm gonna integrate.
you're going to integrate. Now look over here. This is your curve. Can you see this? Can you see your curve?
Yeah.
Okay. This is called the upper bound, and if I want to integrate between x to 0, x will be called the upper bound and 0 will be called the lower bound. I hope you're with me.
Yeah.
In this example, what is the upper bound?
B.
B. What is the lower bound?
A.
A. So if I am going to integrate this function between B to A, I am going to get something which is called the area under the curve. I hope you're with me.
Yeah.
How do you write it? I integrate between B to A, my y with respect to x. Okay. Between B to A, how do you solve between B to A? Can you give me an idea? I write
Between
two
B to A.
brackets. I write two
Yeah.
brackets. Okay. And then B and A, I substitute. Do you remember this or you don't remember it at all? Let's try to do it with one example over here.
Yeah, miss.
I hope you're with me. Are you with me? This is our example.
Yes.
Our function is
Yes.
given to us y is 20 minus x square. Okay. Find the area of the finite region between the curve y is equal to 20 minus x square and the x-axis. Now, since they've given us, I want to find the finite area under the curve. I need to know where my curve hits the x-axis so I can find the finite area under the curve. Yes?
Yeah.
Is it possible to find the finite area under the curve in this example?
Yeah.
How?
We find the roots, right? First.
First, find the roots. How would you find the roots? Put it on your calculator. Give me the roots. Please give me the roots. So I would say this is coming up to 4 minus x and 5 plus x.
Yeah. Give me 1 minute.
Bahar.
Okay.
So what are your roots? Tell me.
My
4
roots
and
are,
minus 5.
yeah,
Your roots are 4 and minus 5. So what would be your upper bound?
4.
4.
Your upper bound would be 4 and your lower bound would be minus 5. I hope you're with me. So if
Yes.
I am drawing this on my x-axis, okay, upper bound is 4 and the lower bound is minus 5. Okay, first let me draw it. 4 and minus 5. I'm looking at integrating the finite area under the curve between 4 and minus 5. I hope you're with me. I hope you're with
Yes.
me. So now I would
Yes.
say my area under the curve is what? I'm integrating between 4 and minus 5. You write the function along with me. It's 20 minus x square with respect to x. Yeah?
Yeah.
Let's integrate it. How do you integrate? Please give me the rules. This one.
Integrating. So
Yeah, tell me. I will add one x and
and
the
divide by 1. So
be
it
the
stays the same.
coefficient of and the denominator would be the coefficient, new coefficient. Okay? Over here. I will add 1 to the power. I will
Yeah.
add 1
And
to the
divide by
power.
2.
Denominator is 2. Okay? Come on. Next.
No. So x cubed divide by 3.
Add 1 to the power and divide by 3. Okay, fine. Now I've integrated this. After integrating, what will I do?
You will find your roots.
I'll write, you've already found the roots. Please be on the loop. Okay? Between 4 and minus 5. Are you with me?
Yeah.
Okay, fine. Now it is equal to what? Come on, tell me. How will I do? I will put two brackets. I'll put the minus. I'm looking for quick answers.
We'll
So
plug in the
you,
answer we got from the integration and
yeah.
plug in the values of the boundaries.
4 and minus 5. So it is going to be 20 into 4 minus 4 the whole square divided by 2 minus 4 the whole cube divided by 3. Are you with me? And 20 minus 5 minus of minus 5 the whole square divided by 2 minus of minus 5 the whole cube divided by 3. Are you with me? Put this on the calculator. You get something as 243 by 2. Okay? Check. I'll wait for you. Please do it. This is your next exam style question. Okay? Here you're given the shaded region R. Can you see that? You're given a
Yeah.
shaded region R. It is bounded by the finite area between 4, 0 and 1, 0. B is the upper bound, A is the lower bound. I would always say I'm integrating between B and A, my function, integrating to find the area under the curve, the finite region under the curve. I'm repeating again, finite region under the curve. Can you tell me what does this denote?
This denotes
Finite
the
region between the bounds B and A.
yeah.
Finite regions between the bounds B and A. I hope you're with me.
Yeah.
Okay, fine. What is your upper bound?
B, which
4.
is 4.
What is your lower bound?
1.
A, which is 1. Okay, so this is my y. My y is 27 minus 2x minus 9 root x minus 16 by x square. And they are saying your x is greater than 0. I want to integrate this function. What is my rule number 1?
So
They're saying use integration to find the exact value for the area of R. Because I do not know further rules, whenever I'm doing integration or derivatives, I would put it in the index form. Anything in the index form. So first thing before I go to integration, I would put this in index form. How would I put this?
so you're gonna
It's going to be 27 minus 2x minus 9. Root x is what?
Root x is just to the power 1 by 2.
X raised to half. How
Yeah.
we write 16 over x square? 16 by x square.
So so we're gonna write 16 x to the power minus 2.
X to the power of minus 2. Now it is perfect for me to do my integration. Now I will write I'm integrating between 4 and 1. I hope you're doing along with me. I'm integrating between 4 and 1, 27 minus 2x minus 9x to the power half minus 16x to the power minus 2 dx. I'll give you time, integrate, give me the answer. I am integrating this between 4 and 1 to find the area of the finite region, right? Tell me the answers that you've got. So it's going to be a big bracket between 4 and 1. Come on, 27 when it's a constant, I put x divided by 1. Are you with me? Please give me answers.
Yes.
Yes.
2x square, you add 1 to the power and you'll divide it by the new power. Correct? Minus
Yeah.
9x. If I'm adding 1 to this power, what will I get?
3 by 2.
X 3 by 2 divided by the new power. So, what would be?
Divide by 3 by 2.
Instead of dividing by 3 by 2, I always do the reciprocal of the new power. Okay, this makes it a bit easier for me. I do it this way. You can do the way you feel it's okay. Minus 16. What is the new power? Add 1 to the new power, whole power.
So minus 1.
Minus 1 divided by the new
Minus 1.
power. Okay. So this is going to be, I will further simplify it. So it's going to be 27x minus x square.
Minus 6x to the power 3 by 2.
Hmm.
Plus 16x to the power minus 1.
Okay. 16x to the power minus 1 can also be written by 16 divided by x between 4 and 1. After this step, you will put it on your calculator, or if you want, if the marks are more, okay, depending upon the question, you can substitute this like this: 1 bracket to the power 4, 1 bracket to the power 1, and you will get your answer, which is minus 12. Come on. Our bounds are 4 and 1 only, right? Come on.
Yeah.
Let's do it. It would be 27 into 4 minus 4, the whole square, minus 6, 4 raised to 3 by 2, plus, sorry, yeah, plus 16, 4 raised to minus 1. Yeah?
Yeah.
Okay, fine. And the same thing would be 27 minus 1 minus 6 plus 16, 1 raised to minus 1. Are you with me?
Yeah.
Okay, fine. Can you give me the value of this bracket that you've got?
1.
So when we are doing it, we are getting our answer as 12. Okay? The dot tip is that substitute this in your calculator, this function, put 4 and 1. You whatever answer you get, as per your steps, simplify, put the steps and come to your main answer. I hope you're with me. Now I'll go to the next part. My next part tells me what happens when the curve goes below the x-axis. Okay, this is the second part, which would be done in 8.3. But we're just trying it over here. Tell me. I want to find the area under the curve between what and what?
Between 1 and 2.
Okay.
No,
I am looking to find at the area of my shaded region.
yeah.
Okay. So I
You
have a
need to go
shaded
from 2,
region
0.
between 1 and 0 that is above the x-axis. I have a shaded region between 1 and 0 which is above my x-axis. And I have a shaded region between 2 and 1 which is
Yeah.
below my x-axis. If I simply look at finding the area of my shaded region, that is my integration between 2 and 0, what I am going to get is 0. Okay, it's a very shocking result, but can you tell me, just by looking at this diagram, is it correct that you get the area of your shaded region as 0?
Yeah, you can get it because one of the shaded areas is in negative and the other one is equally in the positive, so
That is
you
when
get
you're
0.
doing it mathematically and you're integrating and you're finding the area of your shaded region between 2 and 0, you're going to get 0. But
Yeah,
if I do logically, can you tell me, can the area be negative?
it cannot.
Hmm?
It
It
cannot.
cannot be negative because I see there is one area over here and one area over here. So I have an area of the shaded region which is above the x-axis. Then I have the area of the shaded region which is below the x-axis. Yeah. So in this case, what am I
Yeah,
supposed to do? I will integrate between 2 and 1 this curve. Okay. Dx. But I will take the modulus of it. Are you with me?
yeah,
Plus, I'm going to integrate between 1 and 0 this function, the blue one, with respect to x. In that case, I will get a different answer. Do you want to try for this one? Your curve is y is equal to x minus 1, x minus 2. Come on, step number 1. Can I do integration in this form?
no, I'll have to open the brackets.
You'll have to expand it and always try to bring it in the index form. So expand it. Get me the area of the shaded region under the curve. I'm giving you like 3 minutes of time to do this. Now I have to solve this, so I need to show what I am solving. So I'm going to integrate it in two parts, area above the x-axis and area below the x-axis. I hope you're with me. I'm going to integrate in two parts, area above the x-axis and area below the x-axis. So first I would integrate between 1 and 0 my function, that is x cubed minus 3x squared plus 2x. Are you with me? Plus, I am going to take the modulus of integrating between 2 and 1 my same function, that is x cubed minus 3x squared plus 2x dx. Are you with me?
Yeah,
That means this is going to give me a positive area under the curve. But this was the one that is below the x-axis that is going to give me the negative area. So that is why I know area cannot be negative, so we are going to take the modulus of it. Now when I integrate this, the first one, okay? First I need to show this, that what am I doing? Now when I'm integrating this, it is going to be x, add 1 to the power 4 divided by 4 minus 3x, add 1 to the power 3 divided by the new power plus 2x, add 1 to the power divided by the new power. This is my first bracket between 1 and 0. I hope you're with me. Are you with
yeah,
me? Plus I will do the same bracket. When I'm integrating it, I'm going to get the same answer. But now this is going to be the modulus, okay, between 2 and 1. Are you with me?
Yes,
What
miss.
you're going to do after you do this step, you will write 1 by 4 x 4 minus x cube plus x square. Between 1 and 0, you can even open the brackets if the marks are worth it. Okay, 1 by 4 x 4 minus x cube plus x square between 2 and 1. But whatever answer you're going to get for your second bracket, you will do the modulus of it. That means I'm looking at the positive answer. I know I'm going to get a negative answer because the area is below the x-axis. Can you give me the answer for this? I'll wait for you. So when you integrate this and you put the thing under in your calculator, the area between 1 and 0, you're going to get 1 by 4. And the area between 2 and 1, you're going to get minus 1 by 4. I'll take the modulus of this and your answer becomes 1 by 2.